Okay. Um, this is a typical question. Um, Basically, give you a disaccharide, and I ask you a whole bunch of questions about it. And what's the linkage? Why is it reducing sugar? Is why? Um, um, so let's go through this one. This happens to be maltose. But the three disaccharides you need to know: maltose, sucrose, and lactose. So I'm going to do all three of those right now. So this is galactose, and because this is going down, it's an alpha maltose. So you have two versions, alpha, beta maltose. Is it reducing sugar? So need to have a hemiacetal present to be reducing sugar. Okay, so do we have a hemiacetal? Well, we've got OCO, and then we have OCO. So we have two areas that one could be an hemiacetal. So let's take the one on the left first. Okay, so this one is going to be OCO, and we have um, no OH, and we have an H. So that means that is a acetal. Okay, then this one over here, OCO, and we have an OH present and an H present. So that means this is the hemiacetal. Okay, so is it reducing sugar? Yes. Why? Hemiacetal is present. Now, the reason why it's a reducing sugar is the hemiacetal can open up to an aldehyde, and the aldehydes are very susceptible to oxidation. So that means the sugar is oxidized, and whatever's going along with it will be reduced. Okay, there are two main tests I talked about on determining whether there's an hemiacetal present. That's the Benedict's test and the Tollens test. Both Benedict's test uses copper, and the Tollens test uses sugar. And that's what's being reduced when the sugar is being oxidized. Okay, name the linkage. Here's the linkage here. So the linkage is going to be in, there's the anomeric carbon for each one. Okay, and here we have a alpha 1 4 linkage. This is a carbon number 4. Okay, now there is no linkage on the hemi part, only on the full acetal. If it was a ketal, you'd also have a linkage. So the hemis don't have linkages, full-blown acetal ketals do. Okay, so that's going to be an alpha 1 4. Okay, what is meant by the term reducing sugar? A hemiacetal is present. That opens to an aldehyde. Which is oxidized. It's gotta be a hemiacetal. That's the key on reducing sugars. Okay. So let's talk about the other two sugars. Okay, so this is maltose. And you also have to know lactose. Yeah.
For the OCO test, you have to use the O in the middle for both of them.
C in the middle. It's OCO.
Well, I was talking about like, um, so on the left side,
Huh?
you used the. Okay, never mind. Oh,
You-
we're
you
doing it wrong.
You see the OCO?
Yeah.
Yeah. I always put a dot on the anomeric carbon. Okay, so let's look at lactose. Now, galactose and glucose come together to form lactose. So this is going to be galactose. And it's going to be beta galactose. Notice the OH is going to go up and it's going to connect up with either alpha beta glucose. So let's make it a beta. Okay, so this is going to be beta glucose. Could it also be alpha glucose? It doesn't really matter. And to name it, it's going to be beta lactose because the glucose is in the beta form. Okay, well, that's the other disaccharide. The linkage is a beta 1,4. So that's the anomeric carbon going up to carbon number 4 on the glucose. This over here is a hemiacetal, so it's also reducing sugar. The other disaccharide I want you to know is sucrose. Okay, that is a combination of glucose and it's going to be alpha glucose because that OH is going down and it's going to connect up to where to go. How did I jump to chem? Okay, so it's going to connect up to fructose. And it's going to be beta fructose it hooks up to. Because the OH here is going up. Okay, so is sucrose a reducing sugar? Okay, we need to look for a hemiacetal. Is there a hemiacetal present? Well, we've got two OCOs. We've got OCO and we have OCO. So let's look at the top one first. Okay. Okay, so is H present? We have an H there, so yes. Is there OH present? No. So that is not going to be a hemiacetal. It's got to have OH present. So we one on the bottom. CO. Here's the anomeric carbon there. And do we have an OH? No. Do we have H? No. So that's not a hemiacetal. So this is not a reducing sugar. The linkage is going to be alpha 1 for the glucose, beta 2 for the fructose. So in fructose, the anomeric carbon is carbon number 2. So those are the 3 disaccharides. So you're going to have at least one question like this. Okay, what disaccharide has alpha 1, beta 2? That's going to be fructose. And we just drew it. Is it a reducing sugar? No. No. Hemiacetal. Okay, so discuss the structure below in terms of the following. Is it a reducing sugar? Here we go again. Hemiacetal. Well, first of all, there is an OCO. OH present? No. That means it's not a hemi anything. And is H present? Yes. So this is a acetal. So is it reducing sugar? No. No hemiacetal present. Okay, what's the difference between amylpectin and amylose? Okay, amylose is your classic starch. And amylpectin is branching. And it's glucose with a alpha 1,4 linkage. And with the branching, we're branching with a alpha 1,6 branch, which is the carbon on the very top. Now, can also throw in your cellulose. Cellulose has a beta 1,4 linkage of glucose, non-branching. So you've got 3 polysaccharides: amylpectin, amylose, or starch. And let me throw one more in there. Glycogen is the same as amylpectin, only it's a little more branched, but it's basically the same as amylpectin. And that's the only carbohydrate that mammals can create. Glycogen. Okay, so show the reaction of Benedict solution with beta glucose. Okay, so Benedict solution involves copper plus 2. And we've got beta glucose. And it's in an alkaline environment. Okay. And what happens is the copper is reduced. So the plus 2 goes to a plus 1. That's where the name reduction comes into play. And then the glucose opens up to the aldehyde and then it's oxidized. So that's the Benedict solution giving a positive test for glucose. Now this only gives positive tests for carbs that can open up. So for example, if we had maltose there, maltose has got hemiacetal present. Here's maltose right here. And that would also give a positive Benedict's test. So it doesn't matter where the hemiacetal is. If it has one, it'll give a positive test. So this goes from blue to kind of a burnt orange. And it goes fast too. So eventually you're going to do a carbs lab and you'll be doing a number of tests. Okay, if it was a tolerance test, instead of copper plus 2, it would be silver plus 1. Everything else is exactly the same. Okay, so this is what test do you use to determine whether an anaerobic carbon exists? That would be Benedict's test. Or tolerant. So that was one test I gave. I don't know what semester it is, but and then there were draw alpha fructose. Beta galactose. Okay, let's go ahead and go through. I guess this was last semester. Okay, so let's go through these again. Kind of a quick review. Okay, we've got a ketone, a cyclo. Okay, and we've got, um, okay, the function group on a cyclic molecule always, is labeled carbon number 1. So that's the carbon number 2, 3. So it's 2, 3 dimethyl cyclohexanone. Now, test one, some of you, label the carbons as carbon number 1. I think that's a couple of times. But the functional group is on the ring. It's always carbon number 1. Okay, so we have another ketone here. It's 1, 2, 3, 4, 5. So that's going to be a pentanone. And we've got branches at carbons number 1, 2, 3, and 4. Okay, so draw the following structures. Okay, we have a heptanone, 7 carbons. And the ketone is on carbon number 3. And 5 and 6, we've got phenyl groups. Okay, here's a pentanol. And it's 1 pentanol. And we have carbon number 2, we've got 2 methyl groups. Okay. Here we have pentanal. And Al means it's an aldehyde, carbon number 1. And we have on carbon number 4, 2 methyl groups. And on carbon number 3, we have isopropyl. Okay, let's see what else we have. Here's some acetal and hemiacetal reactions. Okay, we're starting with a ketone, so that's going to be a ketal reaction. So the first alcohol that goes on is going to be the hemiketal. So this is the ketal. All right, let me back up. This is going to be a hemiketal. This will be the ketal. So the first alcohol is going to bond to the anomeric carbon, which is that guy there. And then the next one is going to bind to the OH. Okay. It says identify which of the acetals, the hemis, ketals, or nothing. Okay, we got an OCO. Oh, automatically means we've got one of the 4. And we've got is there present? No. There's the anomeric carbon. And is OH present? Yes. So that makes that a hemiketal. Okay, here we have CO, but no CO, so that's nothing. And here we have OCO and a merritt carbon there. So let's look at this, okay. Okay, so is H present? No. Is OH present? No, that makes that a ketal. Okay, put a dot in the anomeric carbon. Okay. So that's basically about the length of your test on Tuesday. And typical, you can have a 3x5 card both sides. And gonna have lab. Lab next week is dry lab. The following week is a soap lab. So next week is a dry lab. Okay. And it's gonna be available on Canvas. No. Okay. Now, if you'd rather, I'm gonna be here for the dry lab. If you'd rather do the dry lab here, I'll have it printed off. Or you can download it at home for those of you who drive incredible amounts. You can download it at home. Okay. Are there any questions about this next coming test? Yeah.
Just like really quickly list off all the saccharides that we have,
I'm sorry, say again?
really quickly list off the saccharides.
Right. I'll just do it right now. Only one illegal saccharide, just raffinose, simplest one. This is like flashcard city. Now, the next unit I needed 3 is on carboxylic acid, esters, and lipids. And there's a lot of fatty acid structures you need to know. Have the same level memorization stuff. That's true, yeah.
You said, pectin is the same as glycogen.
Amylpectin, yes, glycogen is a branch carb, just like amylpectin is. It's more branched actually than amylpectin, but they're both branched. They're branched at the same spot, carbon number 6. Only the difference is glycogen is made by mammal. It's the only carb we make. I shouldn't say that. It's the only polysaccharide we make. We make glucose all the time. Okay, any other questions about upcoming tests? You can always email me or text me. That'll work too. Yeah.
So for the index card, will we print out like a document and then like glue it onto the index card? Because I can't write that small, so if I did it.
That's what I suggest.
Okay.
It's doing it in Word and just printing it small. Yeah. And you can bring in an 8.5 by 11 with a 5 card
Oh, okay.
as well. You know, both sides.
Right.
You don't have to have an actual 3 by 5. Especially if you do it on Word. So any other questions about the test? Yeah.
You post the answers to this already?
What?
The just do it.
Those structures? Or the test? I just want to.
It says that.
I don't know if it's on. I have a lot of practice tests, and some of them have answers and some don't. Chem 131 is the name of the class up in Washington. That's why you see a lot of Chem 131 practice tests, because I taught that for like 16 years up there. Normally, I'll have either key or ANS by it if they're answers. Um, Tonight, I'll print off that one note with the answers and then post that. But I've got a lot of practice tests. Send me a note to remind me. Printing from one that's a pain. It assumes the whole thing is one page wide, in that the pieces. Well, yeah,
Where can I find like the full list of reactions? Is it under like slides or worksheets or
it's go back to the slide.
under unit 2?
Yeah. And then there's 2 sets of slides, one for aldehydes, ketone, the other's for and each one will have a series of reactions.
Is there not like a slide that shows like the full list of reactions? Is there some of them are just like separated in parts?
I can write them down.
Are you providing us with the list of reactions as well?
The flow chart? Yeah. Now, I'll always give you that. Okay, so there are oxidation reductions for aldehydes, ketones. Then there is the numeric reactions for aldehydes, ketones. Then you've got the anomeric tests for aldehydes, ketones. That would be Benedict and Collins tests. Let's see what else. And then all of unit 1 reactions as well. On the slides, there are definitely a series of slides on reactions. For both the aldehydes, ketones, and carbs. And then you've got the flow chart, and you've got unit 1 reactions so far that involve aldehydes and ketones. Where you oxidize an alcohol with an aldehyde ketone. You can also reduce an aldehyde ketone back to an alcohol. Does that make sense?
So for clarification, you get a 3x5 note card and the reaction flow chart.
Yeah.
Okay.
Does the reaction flow chart that we're receiving, that you're providing for us, like, it includes all the new ones as well with the hemiacetyl?
Yeah.
Okay.
Yeah, it's this one here. This guy. What do you guys do? Now, I'm gonna give everyone extra time on Tuesday. Because we have dialogue. Next week, okay? I'll give everyone 2 hours. That's assuming you need 2 hours, okay?
Is it gonna look very similar to what you presented?
All my practice tests, as a student in my class, I would not like to have something different than the practice test. Very similar.
Understand what's presented today, we should be wrong.
To do yeah. Yeah.
So, on this,
It's still on you.
I have them all, but I'm gonna split it up from unit 1 and unit 2. So I'll send it to you, just not. I just don't want it to be like. Yes.
Oh, it's good.
This was those were back in last semester. Semester, in the 4 semesters. You already started teaching the same thing. No, notice I no notes. That's it, that's something that I remember once I thought, that I took this. That's in one. Oh, they have another 3 years down there. Well, we taught this for 20 years. And my class was here. Nice, I can really find how to present stuff. And as I had to walk through older movie, I was going to go back, exactly. I didn't like my coughing. Sort of the last semester version.
Yeah. Well, you're not confident anymore. It's not better. Yeah.
It's too coincidental that the supplement I started taking, my,
Yeah. I remember you were telling us about the pills that you took on Tuesday.
this is actually a liquid.
Oh, it was a liquid.
And I take emerging sleeves, and I just squirt it in that.
Oh, okay. Just mix it in with water and just chug it. Oh, okay.
It's, I'm trying to spraying around directly. And it, weird. It's a little bad. It isn't good either. That's probably.
What drink would you recommend? Like drink, like if you got like you probably know that, right? Like what drink? Well, how would that?
Yes, and
Oh,
I've been known to drink, on numerous occasions. I've never gotten anyone in town.
what? Really? No way.
And sometimes I've been known to drink a lot. That's how I know that, vomit can take pain off cars. Because acid in your stomach comes up.
Oh,
That's why
so you recommend just
That's
just vomit it out just to bring it up. You don't have any longer or what?
No, I didn't, that was not voluntary. The vomit,
That just happened.
well, I didn't drink it all of this. No, I got in the Air Force. I went directly in the Air Force. You know, I remember drinking beer for certain. I made up for it.
Right?
Yeah.
And then we got out of the Air Force, that's when we was school.
Get out of
Yes.
Well, you know, it's good.
No, for sure, yeah.
My parents sent me to college and I've never been drunk before. Oh, you guys are setting me up. Yeah.
Yeah. Oh,
Yeah.
that's the thing.
It's just water.
Yeah, a lot of times it's just having something, that you're drinking. And it can be water. That's why you drink. You need water.
Okay, for sure. I'll remember that next time.
Put it in your life.
Carbonate water? Okay.
I love carbonate.
Humbly's good.
About identifying like the acetyl and ketones and the acetals and ketones when you're doing the OCO. So if there's a hydrogen present, it's either hemiacetal or acetyl. And then if it's not, does that mean it's either a ketal or a hemiketal?
If the H is missing,
Mhm.
that means it's a ketal or hemiketal.
Okay.
If the H is there, then it's a hemiacetal or hemiketal.
So if I was going through the list and there was OCO and there's an OCO and then there's no hydrogen, it's either hemiacetal or sorry, hemiketal or ketal. And then do I also check if there's an OH still?
Because that'll determine what's handier. So
So
OH,
if there
OH means
is,
handy.
okay. So if
And then
it's,
you need to look at the H is there to figure out what's hemiketal, hemiacetal.
okay,
That makes sense?
yeah, and then for these lists of what we have to know, do we just have to know the structure of it, or do we also have to know like the purpose, what it does, how it reacts with things, or do we just need to know the structure?
Structure, and then also how it, during ventilative stress, what happens.
Like how it reacts with the copper?
So in other words,
Like, does it open up? Is that how it works?
first thing is, when it opens up, it exposes.
Mhm.
And outline then what's oxidized, what's acid.
Okay.
And when that's oxidized, something's got to be reduced at the same time,
Mhm.
which is going to be the copper. And those are +2 +1.
Mhm.
And that's why it then changes color.
Okay,
Better?
yeah, I hope so. There, shut up.
So this is wildly different than real.
Yeah, so. It's, I had the same issue in Peter Flyers where I did really well at the start. And then suddenly it just all goes down. It's like too much information. I'm like, I don't know. But we'll see.
I've never talked to it, and I took the equivalent class for Washington, it's called only one, and it was the same as 3 o'clock.
There was certain, I'm really bad with like information. Just, I'm more, of a- I like patterns. I like when this happens, this happens, this happens. But giving me definitions and then understanding concepts is just so much in my head. So in 305, I liked stoichiometry. I love stoichiometry, it was so fun. And now I'm like, oh, like I can do the naming, because those are like patterns to me. And then, but like understanding like intermolecular forces, like kind of what it does, the reactions, that one's I'm like struggling. So that's doing this feel.
We just want to have an IMF.
Yeah.
Whenever you have oxygen in there, fly goes up, it's gonna be polar mode.
Mhm.
Polar. And the reason is because of the way, remember,
If it has oxygen, it's something, okay.
the oxygen, when it binds, it's bent.
So is that saying like the intermolecular forces are dipole, or see, that's like, that's the thing that I'm still like
So
figuring
the
out.
oxygen's there uniquely, look for dipole, or hydrogen bond.
Mhm.
And hydrogen is stronger than dipole.
Yeah, I feel like a lot of those are just memorization. I'm so bad at memorizing.
Well, if you remember the oxygen,
Mhm.
everything is below that. Whenever you have oxygen involved, you can have it as an ether,
Okay.
and be dipole from the CO and the CO. Two dipole.
Mhm.
Or if you have alkyl ketone, then you have double bond. That's a dipole, yeah. And then you have alcohol, hydrogen bond. And you always have limited dispersion.
And is that just if the structure has those things, or is it if it's connected to the inner carbons, or is it just if the structure contains those?
It doesn't have to be, have an intermediate carbon. It can be any structure. Carbon, oxygen is there. It's polar, how polar is it? Look for OH.
Okay, thank you.
Your lunch today,
No, I had it Tuesday.
did you like it?
Yeah, it was fun.
I think it's cool with all the last story on.
Yeah. But, yeah, I would say it's pretty fun. Yeah, it smells good too. I liked it. Alright, bye.
It's gonna be one. You see, your numbering starts at the OH. Not yet. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And one. So well, that's gonna be right. Nothing right. That's gonna be 2 and 4. That makes sense? Yeah.